Hello, it's Mr. T here. Today is the fifth video I'm doing on my science physics topic, and we'll be looking at distance time and speed time graphs. Now, here is a graph of a journey that someone's taken on a bike, and it's been plotted. The time from when they started the journey and the distance away from their start has been plotted on as they go along their journey. So at this point here, this level point on the graph, the gradient of the graph is 0. That means the distance that the person is traveling is not increasing compared to time. That means that at that point, and you can see the distance at is 9 meters, and the distance has been 9 meters from about 30 seconds to 50 seconds. The person must be stationary at that point. So on a distance time graph, a horizontal line means the object is stationary. If there is a straight line and it is moving at a gradient, an upwards gradient, it means that the person is at a constant speed and that they are moving away from where they started. They're going further away. We can see for this line here, they've gone from 7 meters to 14 meters away. And they've done that from 50 to 70 seconds or over the course of 20 seconds. This object, this bicycle, has been traveling at 0.27 meters per second. And we can see that it's traveling at a constant speed because it has a straight line on an angle. We can see at this first part here that there isn't a constant straight line, and in fact the gradient of this line is increasing because it's curving upwards. If you see a curve on a distance time graph, it means there is acceleration. In this case, it is accelerating away from the starting point, and that's because the gradient is getting steeper. The last point we need to note here is if the gradient is going downwards, then it means that the object is going back to where it started from because it has a negative gradient. We can also see at the bottom here there is a curve. So what's happening is the gradient is getting less curved. Now that would mean the object is accelerating again, and in fact it's slowing down, or we could say it was decelerating. Okay, so here is another distance time graph. There are 3 different sections of the journey here. We can see there's the first one where an object is moving away from its starting point at a constant velocity, and we could calculate the velocity, it is the gradient. And then we see the second point where the object has a horizontal aspect to its journey, so it's stationary, and then we see the object again is moving at a constant velocity. Now, if we actually want to measure the velocities or the speed that the object is traveling, the velocity or the speed the object is traveling, I want to know what the speed is. I can do that by measuring the gradient. Let's measure the speed of this part of the journey, of this straight line. To measure the speed of this straight line, I need to measure how far it went and divide that by the time that it took to go this part of the journey. To do that, I draw 2 straight lines horizontally from the start and the end of this part of the journey, and I find the change in distance between these two. So that's 12 meters minus 5 meters. Then I want to draw 2 vertical lines from this section, and I want to find the change in the time. So the change in the time here is 8 seconds minus 5 seconds. So we can see here that the object has had a change in distance and a change in time. Now, we know that if we take a change in distance and we divide it by the change in time, that will give us the speed of an object. So let's have a look and calculate this. The speed of this object equals its change in distance, which is 12 minus 5, over its change in time, 8 minus 5, or 7 divided by 3. The velocity or the speed for this object is 2.33 meters per second. Or if we round this to two significant figures, the speed is 2.3 meters per second. Now we could calculate the speed for any part of a straight line on this graph. If we did it for the horizontal one here, we would get a change in distance of 0, and we would divide it by a change in time of 3, and that would give us an answer of 0 because it's a constant speed. If we did it for the first one, we would have a change in distance of 5 divided by a change in time of 2, and we would get an answer of 2.5, and we would see that actually in the first part of the journey it had a higher speed. It was going at a faster speed. So this is basically what we need to do for distance time graphs. We need to calculate the speed of a distance time graph. The only other thing you might need to do on a distance time graph is describe what the journey is at different places. And we looked at that at the previous slide. We could say it was accelerating, it was a constant speed, or it was stationary if the line was horizontal. Here is what we call a speed time graph. So now what we've done is on the left-hand side of the axes, we've plotted the speed at any time in the journey instead of the distance. And on the horizontal axis, we've plotted the time. Now, a gradient on a speed time graph actually represents acceleration. And if the gradient is increasing, it means the object is accelerating. If the line is horizontal, if it's flat, it means that the object is going at a constant speed. And we can measure that constant speed by going across to the vertical axis, so taking the line across the vertical axis, and we can see there that the vertical speed of this line is 6 meters per second. If you have a steeper angle, it means you're accelerating at a greater rate. So this has a larger acceleration than this. If your gradient is negative, it means that you are decelerating or have a negative acceleration. So you can either say that this is a negative acceleration, give a value with a negative in front of it, or say that it is decelerating. So these are the important parts that we might see on a speed time graph. We might see a flat or horizontal part of the journey. In that case, it's at constant speed. We can read it off from the left. We might see an increasing gradient. In that case, it is accelerating. Or we might see a decreasing gradient. In that case, it is decelerating. So for these gradients here, we need to work these out. Okay, so here's another speed time graph. It has three sections of the journey. It has this first section. We can see that the speed is increasing, is accelerating. We have this section here where the speed is staying constant, where the horizontal line is flat. So it's got a constant speed of 15 meters per second. And we have this part here where the speed is decreasing. Again, we can calculate the gradient in the same way we did with distance time graphs. We're going to put two horizontal lines. I'm going to calculate the gradient of this section here, so two horizontal lines from its start and its finish. I'm going to find its change in speed by subtracting the final value, taking the final value, which is 0, subtracting the initial one, which is 15. This might seem a bit counterintuitive or a bit backwards, but you can see if I do 0 minus 15, I will get a correct answer. That is that the velocity has actually decreased by 15 meters per second. Well, let's calculate the change in time. I'm going to take the final value and subtract the initial one. So our final value is 14, our initial is 10. So we get the change in time is equal to 14 minus 10. Okay, so now we can find the gradient. The gradient is the change in the y value divided by the change in the x, or change in velocity divided by time, which we know equals acceleration. Acceleration equals change in velocity over change in time. So let's put that into our formula and we come up with an answer. Negative 15 minus 4. This gives us an answer of negative 3.75. When we round this to two significant figures, remember because this is a 5, this next value is going to round up to 8. So we're going to get negative 3.8 meters per second per second. The negative value means that it is an acceleration, but it's slowing down, not speeding up. It's decelerating. So the negative means it's decelerating, which we can clearly see from this graph. So we're happy with this result. Okay, so using these speed time graphs, there's another technique that we need to be able to do, and that is to work out the distance of a journey. Now, to work out the distance of a journey, we can take another speed time graph and we can calculate the area that is under this line of the speed time graph. Now, I'll show you what I mean by this. If we can break the area under the graph into triangles and rectangles, we can calculate the area of each one of those shapes. The area of a triangle equals half the base times the height, and the area of a rectangle equals the base times the height. Let's have a look at this first section here. That's this point here. I'm going to call it X. This is a triangle. The area of this triangle is half the base, which is 5, times the height, which is 7. Half 5 times 7. The area here is 17.25 meters. That's the total area under here. This is actually the journey, this is the distance that the object has gone up till this point, 17.25 meters. Let's find the area, and we're going to have to now break the rest of this into, the easiest way to do this is to break it into two shapes. I can break it into this rectangle here and then this triangle. Let's find the area of this rectangle. So the area of the rectangle is just the base times the height. Now we can see we have 15 here and 5 here, so the base is 10 long and it's 7 high. So the area of y equals 10 times 7 equals 70 meters. The last section is this triangle here, so let's work out the area under this triangle. So this goes from 12 to 15, so the base is 3 and the height goes from 7 to 12, so that's 5. So half 3 times 5 is 7.25 meters. Now, if I want to find the total area under this graph, that will give us the distance that this object has traveled over this journey. So if I add the area from X, Y, and Z, let's do that. X, Y, and Z, we get a total area. And the total area under this graph is the total distance. Now the reason that works is because what we're actually calculating when we calculate the area is we're calculating that the distance equals the time times the velocity. When we multiply time by velocity, we actually just get the distance. And this is how we calculate the area under a speed time graph. Okay, so in this video we've looked at distance time graphs, and remember we can explain a journey by, on a distance time graph we have the an angled gradient is equal to a velocity, and a straight horizontal line is means that there is the object has stopped, and pretty much that's the end of how we use a distance time graph. However, when we get to a speed time graph, we now have an upwards angle of our gradient equals acceleration, a horizontal line equals constant velocity, and a downwards angle on our gradient equals deceleration. And we can calculate the gradients using the calculations we looked at. And then we had this third idea here is that, look, if we take all of the area under a graph and we use these shapes, okay, to find out So we use the triangles and rectangles to find out the area under the graph. That will actually tell us the distance that the object went when we're working with a speed time graph. Okay, thanks. I hope this video has been helpful, and look out for the next one.